All right, this is Unit 2.2, the Calorie Lab, or carbon-based molecules. In this lab, you're going to experimentally find the calories of 4 food samples and compare those to the calorie content on the nutrition label. A calorie is a unit of energy. It's the amount of energy needed to raise 1 gram of water 1 degree Celsius. So this is a small amount of energy, and not actually what we see on the nutrition label. The nutrition label shows the food calories, or calorie with a capital C. So there are 1,000 of the small c calories in each kilocalorie or food calorie. So what we're going to be using is a calorimeter. This is the combustion chamber. You'll have a thermometer in degrees Celsius. You'll have an Erlenmeyer flask. You'll see that in a second. A 50 milliliter graduated cylinder, distilled water, a food sample, a wood splint. That's the Erlenmeyer. You'll have a collar, some aluminum foil, etc. You'll also have a data sheet to enter the data that you find in that. So the collar just pops off and on, and that metal top is just used to suspend the Erlenmeyer flask over the burning food. So there's the matches. Okay, so make sure that your Erlenmeyer flask is dry. You're going to use 50 milliliters of distilled water. In your data sheet, you'll see it says mass of water. You do not have to weigh the water. You are going to use the fact that 1 milliliter equals 1 gram. If you have 50 milliliters, exactly, you have 50 grams of water. You're also going to get one of the 4 food samples and write the sample identity as well as the calories per gram for that particular food sample. Once you get your 50 milliliters and you're looking at that so that the meniscus is at the 50 milliliter and you're looking at it at eye level, you're going to pour that into the Erlenmeyer flask. And you're going to take the temperature. In your data sheet, you'll record this under initial temperature in degrees Celsius. So if you do have a thermometer that has Fahrenheit and Celsius, make sure you're recording this in degrees Celsius, under initial water temperature. Then you're going to place the thermometer in the protective case so that it doesn't get broken or fall off. Then you're going to place the metal top of the combustion chamber first. Then you're going to put the flat side towards the metal top. This holds the Erlenmeyer securely above the burning piece of food. You're going to place the Erlenmeyer inside the combustion chamber, making sure that the lid covers the entire top. You don't want any heat escaping through a gap in the lid and the combustion chamber. Then you're going to mass the foil, paper clip, and food sample of your food sample. It's better to put the food sample on the paper clip first, so if a piece falls off, you're not weighing that. The reason for the aluminum foil is to catch any pieces that fall off during burning. And then you're going to put that under, in the second row, the mass of the paper clip, aluminum foil, and food sample unburned. And you'll record that. That foil, make sure that you don't have any experimental error of a piece falling off and being in the combustion chamber, and then it appears that more of that food sample burned than actually did. Then you're going to place that food sample so that it's directly under the Erlenmeyer flask. You can pull the paper clip a little further apart. You're going to place the container over the material, again, making sure that it's as close to the Erlenmeyer flask as possible. You'll take a wood splint. You'll light the wood splint with a match. Once the wood splint is burning, put the match in the bucket with water, and then you place the splint into the combustion chamber and set the food on fire. Once the food is burning sufficiently, put the splint in the bucket with sand because you can reuse the splints. And then you're going to allow the food to completely burn. If it goes out, you can take the splint and relight the food. You do not have to burn the entire amount of food. You're going to weigh it and look at how much of the food did not burn. So if some of it doesn't burn, that's fine. Okay. Then you're going to take the temperature of the water. Be sure that when you handle that, it's hot. There will be tongs there if that does get hot. The paper clip is also very hot. You're going to put the thermometer in to measure the water temperature while you're weighing this. And you're going to record this in the row for aluminum foil, paper clip, and burned food. And then you're going to record once the thermometer stops moving under final temperature. Remember, you must be wearing full gear the entire time. Hair has to be tied back, nothing hanging, no strings, because you are using flames. The paper clip and the combustion chamber may get hot. And to clean up, you're going to disassemble everything. You're going to throw out the food, clean out your Erlenmeyer flask, put your thermometer in its protective case. You don't have to dump the bucket with the matches, but you do have to clean up everything else. Take the collar off the Erlenmeyer, wipe any charcoal off the bottom of the Erlenmeyer as well.